So the biggest key to remembering how to flip back and forth between logarithmic and exponential is the base is the base. The base of a log is the base of an exponent. The base of an exponent becomes the base of the log. Okay, those bases are, once it's a base, it's always a base, right? So as we look at this first one, I think through things exponentially. So if I were to solve this one, I would think through it as 2 raised to this equals x, right? 2 raised to this equals what's inside. And I, again, think exponentially a lot better than I think logarithmically. So I almost exclusively write all of my logarithms as exponents to be able to think through how to evaluate that. Anytime I have something raised to a negative number, that means drop it to the bottom of a fraction. So if I make this a fraction, I would drop that 2 to the bottom of it, which would leave me with a 1 in the top, and now a 2 to the first in the bottom, which is just 1/2. Okay, so in this case, x would equal 1/2. Okay, same thing on this one. I would think exponentially 2 raised to the 0 equals x. If it's raised to the 0, what's x? 1. Anything raised to the 0, right? Anything raised to the 0 is 1. So x equals 1. And here, 2 raised to the first equals x. What's x? 2, right? X would be 2. So the question at the bottom is, how can we use these values to graph a logarithmic function? Remember that when you have something like this, if it's the log base 2 of x, what's this representing? X is right here. The other one, y, right? If it equals something, it equals y. This is the same as y equals log base 2 of x. And it's saying this is our y's and this is our x's. So we can kind of use this to help us think through how we would graph this. If I want nice, pretty numbers, I'm actually going to make these my y column, which is very backwards of how we graph usually. We're going to kind of cheat the system today to make it nice, is I want nice numbers. And so we're going to kind of think backwards. This list should look familiar. Don't we use this list of 3 numbers all the time when we're graphing? Okay. But today, notice that's going to be in our y column. And we're going to strategically pick numbers so that is our y column. Okay. And so that's what we're talking about today. We are talking about graphing logarithms today. I will tell you right now that the properties of logarithmic and exponential graphs are very similar. And so if you were to flip those, you will kind of hurt yourself big time on the quiz and test. So the things that you want to make sure that you study for that is the difference between logarithmic and exponential: domain, range, and asymptote. Those are the 3 things that we always ask about on those 3 properties. What is the domain, the range, and the asymptote of each of those functions? Exponentially, your domain was unrestricted. Your range was specific to the picture, and you always had a horizontal asymptote that moved if your graph moved up or down. Okay. Today, it's going to be very, very similar, but they are inverses of each other. So everything ends up getting flipped. So by the end of today, we'll be able to graph our logarithms, find the domain, and then graph natural logarithms, talk about the log base e. Okay. So how are we going to find our table of key points? Typically, we started in this x column. Everything we've always done is plugged in x's. But we're going to kind of think backwards, and this is not really how this is supposed to work, but it is the inverse of an exponential graph. Exponentially, we would have put -1, 0, and 1. Don't write that because we're going to erase it in your x column. But remember, the inverses, we flip all our x's and y's. And so what we're going to do is flip that to our y column. But in order to do that, we have to strategically pick our x's for this to happen. Okay, so here's how we strategically pick our x's. In that top row where it says -1, we have to put in the reciprocal of the base. Our base being 3 here means I would put in a 1/3 in my x column. Again, thinking backwards exponentially here, if I raise something to the 0, what do I get as an answer? Always 1, always 1, right? And then here, if I raise something to the 1, I always get that same number. This will always match your base. Okay, always, always, always. It is thinking backwards, and I understand that, and we don't typically do that, but we're creating nice points for us to graph here, so we're always going to go with the reciprocal will give us a -1. 1 would give us a 0. If I plug 3 into this function, it would give me a 1. Graphing those points in my picture, we're going to have to approximate the 1/3, comma, -1. 1, 0 would be here, and then 3, 1 would be here. Now, what we didn't really talk about yesterday in our video of logarithms is that logarithms have a domain restriction. If you were to have typed in your calculator, which you did not do because we are not using calculators on this, but if I were to try to type in my calculator something like the log of -5, it would yell at me because logs cannot evaluate negative numbers. If we think about this, this is saying that 10, right, base 10, raised to something gives me an answer of -5. Okay, well, I can't do that, right? Because if I raise 10 to a big number, it's just going to get big. If I raise 10 to like a negative number, it's going to give me small fractions, right? If I raise 10 to a fraction, it's going to give me smaller numbers, never negative. So you can't ever get a negative, which means this is not in the domain. What happens is the domain has to be, must be greater than 0. So what's going to happen is we can't plug in 0. We can't plug, because I can't raise 10 to something to give me an answer of 0. And so it's going to get really close to, but never get to 0. So it slides along here. I can plug all of these x values in. It's going to go through my points, and then it's going to increase very slowly, opposite of an exponent that increased very quickly, right? And so what it's doing is it's getting close to, but never getting to. That's called an asymptote, right? And this time our asymptote is a vertical asymptote. It will always start as a vertical asymptote at x equals 0, and we'll talk about transformations. Vertical lines are of the format x equals. We'll talk about transformations here in a couple slides as we look at moving our graph around and when our vertical asymptote will also move. This right here, understanding how to build your list of key points, it's all based off of the base. So 3 is not a transformation. 3 tells us how to build our table, okay? So what if that base becomes a fraction? Log base 1/3. Same exact idea. I still want to strategically pick my x's so that I get a y column that reads -1, 0, 1. And in order to do that, we do the same thing as we just did on the last page. Reciprocal, 1, base. Always goes with those. But this time, if it's a fraction, what's the reciprocal of 1/3? 3. So up here with the -1 would be the point 3, comma, -1. And then always 1. And then our base is 1/3. And what you'll notice is then as I graph these, 3, comma, -1 is down here, 1, 0, and then this time 1/3 is up here. Again, it can never be 0, so it's going to slide really close to 0, but never get to that axis. Go through those points and decrease very slowly. It flipped. When we have a fraction base, it's going to be decreasing as we go across. When we have a big base, it's going to be increasing as we move across. And again, getting really close to, but never getting to our y-axis, which is a vertical asymptote of x equals 0. But if you understand how to build your table, you're good. Okay. Any questions so far? All right. So then what if we change this? Yesterday you guys learned about this natural log. What's our base? E. Okay. So if I follow the same rules that I just did on the last page, I want my y column to end up being -1, 0, 1. And to do that, I would strategically pick the reciprocal 1 and the base. Now here's the problem, and I would not write this, so pause just a second before you write this down. My base is E, right? 1, and the reciprocal of E is 1 over E. The problem is, where the heck is E, right? That's a weird thing to graph. And so what I want you to do is You're going to memorize two numbers right now. 2.7. Hopefully we may remember E. It's the reciprocal that you're really going to have to memorize. So E is 2.7. We're going to approximate to a tenth here. Is this guy right here that you do not get a calculator for this, so we're just going to have to remember this number. If you had a calculator and you typed in 1 divided by E, you would get like, it's like 0.367 or something like that. We'll just say it's approximately 0.4. And again, as we're graphing this, it's going to be approximate. So 0.4, comma, -1, 0, 1, and then 2.7, up 1. It does the exact same thing as we just saw. It's going to slide along that 0, go through my points. And it continue to increase slowly. I will tell you right now that your asymptotes, whether they are vertical or horizontal, are not a requirement, but people tend to not draw these correctly if you don't draw that in there. Because if I were to let my graph drift past that y-axis, continue towards the left, it's wrong. It cannot actually ever get to the y-axis. And so that's why I will always draw on my asymptote as a barrier to remind myself that I should not draw past that barrier. Questions? Those are your basics, okay? If you, again, understand this to build your table, now we just need to apply our transformations to all of these. And to have our conversation about transformations, we do need to understand what is considered inside and outside of a logarithmic function. So, and we always have this conversation, right? Inside versus outside of a function. Log base 5 is the function, and 5 is not inside or outside. 5 is what we build our table on. It is not a transformation. It is our parent function. If you have a multiplication or a negative sitting in front, or you have an addition or subtraction. Now that addition or subtraction could be in front or behind, as long as it is not grouped in parentheses, it is all considered outside your function. The only thing that is going to be considered inside your function will be grouped in parentheses, with the exception of one thing that would not necessarily, but especially if it's a plus or minus, it must be grouped in a parentheses to be considered inside your function. Technically, something like log of 2x, that 2 is inside, and hopefully we understand that. It can be written as this, or it can be written as log of 2x, and those are the same thing. But something like log of x plus 1 is not the same thing as log of x plus 1. And do we see the difference in those, right? These are the same, and both of those 2's are considered inside, but that one is outside and that one is inside. Brady. Correct. You have to have parentheses if it's addition or subtraction, yes. I just want you to be clear because I don't want it to be, well, you said it has to be inside, it has to have parentheses. Yes, unless it's a special case where it's just multiplication, then it's optional. But addition and subtraction, that parentheses is not optional, and it means a lot to the inside outside, okay? So then let's just go through kind of that cheat sheet thing that we have for our transformations. Continues to kind of match what we had on our cheat sheet when we first learned transformations. Again, as I attack a transformation, I start at the very top of this and just address each level as we go down. Does it have that? And if it does, I address either the table or just counting. In that top level, the reflections would be any negative that shows up in our function. If the negative's outside, remember how we addressed that is in our table. We went down our y column and we changed the signs on all of our y's, called an ROX. That's all I have to do. I've taken care of that negative outside by just going down the y column and changing all the signs. Okay. Similarly, if that negative shows up on the inside, that it is a ROY, and an ROY goes down our X column. And to address that, since we are going to graph from a table, we're just going to change all signs in X column. Okay. Then similarly, so I have now looked for all of my negatives. Now I move down to, is there any multiplication? If the multiplication happens on the outside, this is the one where we have to pay attention to, do we change it or not, right? On the outside, we use what is exactly there. So I would multiply the outside, multiply the y column by what is outside. So I multiply my y column by 3. If that moves to the inside of my function, it is now a horizontal, and everything horizontal, we have to think opposite. So we impact our x column by multiplying by the reciprocal. So if I had a 3 on the inside, I would have multiplied by x column by 1/3. Would have been a horizontal shrink by 1/3. And then once I have done that, I stop impacting my column. At this point, I would lightly dot out everything I've got in my table, and I would just count to get my final picture if there's any addition or subtraction, right? So remember, ILROUD, inside is going to move us left and right, opposite of what we think. Outside is going to move us up and down, exactly what we see there, and then the difference between whether it's grouped in parentheses or not, okay? The only other option you could see is I could have something like 5 plus log base 2 of x. That would be a movement up 5, right? If I made that a -5, it'd be a movement down 5. Know how you can move things around here. But this is your big key here too, is that the difference between exponential and logarithmic. Logarithmic, it's movements left and right. It's a vertical line. So think about that. If I moved it up and down, isn't it the same vertical line, right? But if I move it right or left, now doesn't it move across my graph? And so that's why our movement left and right will impact our asymptote as we are looking at transformations. Questions? Does anyone still need this page? Okay, let's do some transformations. Very similarly to what you guys saw in your exponential graphing, they will say use the parent function, use the graph of f of x equals log base 4 of x to graph g of x equals log base 4 of x plus 3. Okay, so remember, the entire purpose of f of x equals log base 4 of x is to create my table of favorite points. 4 is not a transformation. 4 is how I build my table. For logarithmic tables, we kind of think backwards, but I want my y column to end up as -1, 0, and 1. And to do that, we will always go reciprocal with the -1, 1 with the 0, and base with the 1. So our base is 4. Its reciprocal then would be 1/4. So I just run through my transformations. Are there any negatives? No, move on. Are there any multiplications? No, move on. Are there any pluses and minuses? Yes, we have a +3. Is that +3 inside or outside? Outside, okay, so outside moves us which direction? +3, up. Is that going to impact my asymptote? No. It is not going to impact my asymptote, so I will start by drawing my asymptote unchanged at x equals 0. Guys, I cannot stress enough, these 3 things below your graph, know them. With logarithmic, it is a vertical, x equals 0, okay? Then I'm supposed to take each of these dots, which I can put out here at 1/4, comma, -1, 1, 0, and 4, 1, and I am supposed to move each of those up 3. So I just take that dot and go 1, 2, 3, 1, 2, 3, 1, 2, 3, slide along my asymptote and increase slowly. Okay. The domain and range are also going to be different than what we had for exponential because now our domain is restricted. It is restricted, go to your asymptote. Your asymptote, do you remember in my video for the last one is that I talked about how your range and your asymptote should have something in common. This time our domain and our asymptote should have something in common is because your domain is going up to your asymptote. So our domain, the farthest left this graph is going to go, it's going to get close to but never get to 0. And it goes to the right forever. But your range is actually unrestricted. Notice my down arrow and my slanty arrow up here that says that we are going to slowly keep getting higher forever. Says that actually a logarithmic graph will go down forever and up forever. So it has an unrestricted range. Any questions on that? All right, let's see a couple other variations. This time I'm going to let you try to build your table ahead of me, and then I will jump in there to do the transformations part of it. All right, let's start with that table. We should use our basic log base 2 of x. As I walked around the room before I even gave you the problem, this is what I saw, and I loved this. I saw somebody already had their table filled in like this because you know that that's not changing, right? And then we just fill it in specific to our base with our reciprocal at the -1 level and our base at the 2 level, or at the 1 level here. Our base is 2, the reciprocal would be 1/2. Okay, start at the top of your transformations options. Do we have any negatives? Yes. We have a negative outside of our logarithm, right? If it's outside, is that an ROX or ROY? X. Anything outside of our function impacts our y column. So I'm now going to go down my y column and I'm going to change the sign on all of my y values because of the ROX. Do I have any multiplication? No. So at this point, I would lightly dot out my graph, but pause for a second before you draw your asymptote. Is our asymptote going to move on this one? Yes. We do have a movement right or left, so I will have to move my asymptote, so I'm not going to draw that one yet. But I would have the points 1/2, 1, 0, 1, and 2, -1 would be my original points. And then my last movement here is, right or left? Right. And because I said right, we are also going to move our asymptote right 1. And then I'm going to take each of those green dots and move them right 1. And if they are crossing over your asymptote, something went wrong. It should now still continue to slide up next to my asymptote here. So take this and move it right 1, right 1, right 1, slide along my asymptote, and decrease slowly. Okay, so our asymptote did move to the right 1, so now it's over at x equals 1. Careful on your domain. What's our domain? 1 to infinity, right? Those should be related to each other somehow, some way. One of those numbers shows up in there. And then our range will never change. We never have to think about range on logarithms, -infinity to infinity. Questions? Okay. I think we have maybe 2 examples left here. We get the rest of our types of transformations in here. So on this one, we've got log base 3 of x, and we're going to graph log base 3 of -1/2 x. Build your table of favorite points. All right. So building my table of favorite points, I put that -1, 0, 1 in the y column. My base is 3, so its reciprocal is 1/3. Okay, start at the top. Do I have any negatives? Yes, this time it's going to impact which column? X. It's a ROY, right? So it's going to impact my X column. Anything inside impacts my X column. ROY, so ROY. We're going to go down our X column and switch the sign. We are now done with the negative, right? We have another transformation also on the inside of our function, right? Horizontal what? Stretch. Always we think opposite. Horizontal stretch by reciprocal. Anything inside impacts our X column. So now I'm going to go down my X column and multiply by the reciprocal of what we saw on the inside. So multiply by 2. Now, I understand that you will not have a calculator, but can you take 2 times 1/3? It's 2/3, right? Well, think about, if you need to write it out, do this. Make it a fraction. Fractions, we multiply straight across the top, straight across the bottom, right? It is 2/3. So I just don't want you to panic and say, well, I don't know what 2 times 1/3 is. I think you can do that. If you need to write it out so you can see what's going on, 2 times 1/3 is 2/3. okay? That's the last of our transformations. So now I'm gonna go put those dots in my picture. Negative 2/3, comma, -1. Negative 2/3 moves left 2/3 down 1. -2, comma, 0. And then -6, comma, 1. It got stretched wider and flipped over our y-axis, right? So did my asymptote move? No, I did not say the words right or left, did I? So our asymptote is not going to move, and this is a huge key right here, but our domain will be a little different because now we've flipped over the y-axis. I still slide along my asymptote, but my points lead me towards heading to the left, don't they? Increasing slowly that direction. So now as I answer my domain, what is the farthest left this graph goes? -infinity up to 0. So yes, that asymptote shows up in your domain, but this time it's heading to it from the left, so it ends up being at the second number in your domain. And our range will never change, -infinity to infinity. Any questions? All right, we need to graph a natural log. See if you can remember that table without cheating. Try not to look back. See if you remember that. What's basically one key number in there you need to remember. Luckily, it's the same one for your exponential. It just shows up in a different column. All right, remember our base is E, but it doesn't mean a lot to me to write E in my table. We're gonna approximate to our decimal here. E is approximately 2.7 and its reciprocal is just a number we're gonna have to remember, approximately 0.4. Start applying our transformations. We do not have any negatives. So then we move down to our second block down there, which is, do we have any multiplications? And this time we do, right? On the outside things impact which column? Y column. We multiply exactly what we see there. Outside things are exactly what we see. So I'd multiply that Y column by a 2. Inside +1, which direction? Inside. Left. Always backwards of what we think, right? Left. 1. Oh, I just said the word left. What also is moving left? Asymptote. So move my asymptote left 1. My whole graph should move towards that and slide right along it. Initially, these points were at 0.4, -2, 1, 0, and 2.72. So I got vertically stretched taller. But I'm going to move each of those to the left 1. Slide along my asymptote and go through those points. My range will never be restricted. My asymptote did move left 1. And our domain should go up to -1 and then to the right forever. What questions do you have? All right. I'm going to go ahead and leave it on this page. I'll come back to this. We do have a worksheet today just to show you. You'll scan it and put it on Google Classroom as assignment number 46. There is now.